As the action potential travels along the axon, repolarization takes place on the parts that the electrical impulse already took place. What happens in this state is that the voltage-gated potassium ion channels in the membrane of the neuron will open and let potassium ions out of the cell to the extracellular fluid, making the cell go back to its negative state again, and sodium voltage-gated ion channels will close. And what happens is that the negative charge of the membrane potential goes way too far, causing the cell to go more negative. When a cell's interior is more negative, then it's said to be hyperpolarized. What happens during this state of hyperpolarization is that potassium voltage-gated channels start closing. Throughout all this happening, since the potassium ion channels are closed, you will ask yourself, how in the world are we going to go back? I mean, not we, like the neuron, right? We'll go back to resting state. Like how? And I will say to you guys that is thanks to the best machinery of the human body, the sodium potassium pump. The sodium potassium pump is located in the membrane of the neuron. So it happens that this pump, with the help of ATP, for every 3 sodium ions that the pump lets out of the cell, the pump will move into the cell 2 potassium ions. And this, mis amigos, will bring back the neuron to its resting state of negative 70 millivolts. Now, a quick thing to say. You will ask yourself, does the neuron really generate the electrical impulses super fast and super fast and super fast every time, like super, like boom, 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 boom? And the answer is yes, but it has its limitations and regulations. What happens is that even though all of the ion channels are open in the axon of the neuron and the action potential is still going, the neuron will not generate an action potential even though the impulse is super strong. No matter how strong it is, the action potential will not be generated by the neuron. This is called the refractory period, which prevents the neuron of sending an electrical impulse to both directions at once, up and down. And also, this prevents the super quickly generation of an action potential, because the neuron says, hey bro, we gotta rest a little bit, like calm down a second, you know. Oh, that was a lot to take, right? But you're asking yourself, well, what happens next when the action potential reaches the final length of the axon, and how does the neuron actually sends messages to other neurons? That you will see in another video.